Hi, I'm Elise Naramore. This is part 3 in which you will learn what a learning progression is, how it is developed, and how it is used. So let's continue our journey in exploring putting the learning progression method into action. This is the video series Putting the Learning Progression Method into Action. We are in Module 3. A learning progression is created when a teacher breaks down a practice into developmentally sequenced levels of proficiency. Instead of deducting points for what students cannot do correctly, students are assessed on what they do, know, and can do. The teacher gives feedback based on a specific language presented in a rubric. One of my favorite things about learning progressions is that they are used all year long so that you can track growth. They are general enough to apply to categories of assessments, so students don't need to read and interpret a new rubric for each assignment. This feature enables students, teachers, and parents to track growth over time, as students can target what they need to do to improve performance on that type of assignment. There are 6 important features of a learning progression. There should be a clear pathway for the development of specific skills. Content is the medium for learning the practices, but specific knowledge is not the focus of the learning progression. Language must be specific for each progression. You don't want to use generic language. The skills described should be general enough to apply to a wide variety of assignments. Descriptors should not be specific to one assignment, or students won't be able to practice enough to achieve mastery. Assignment-specific information goes on the actual assignment itself, not on the rubric. The language focuses on what students can do, not what is missing or weak. Positive language reinforces foundation building. The levels within the progression mirror the natural progression of skill development and/or knowledge attainment. For example, it doesn't make sense to define a physics term until the relevant vocabulary is used within the explanation. As discussed in Module 2, when we detailed the 10 practices, each major category of assignment is assessed with a set of practices. Our rubric for labs includes experimental design, data analysis, arguing a claim, and using feedback. Our rubric for a checkpoint or a quiz test includes problem solving, creating explanations, and creating and interpreting graphs. And projects are assessed by engaging with content and the engineering design process. This works great. It limits our time and focuses student attention on a small handful of tasks at a time. Plus, there is inevitably some overlap between the learning progressions. For example, as we said, arguing a scientific claim has similarities with creating explanations, but we use one for labs and the other for tests. On labs, we could have, but don't directly assess creating graphs because we know that we do this on tests. We just fold that skill into data analysis portion of a lab report. In this way, we hit essential skills over different practices without overcomplicating the assessment practice for either the teacher or the student. After much deliberation and going back and forth, we found that these 6 levels work well for students and for us. In order for students and parents to really see progress, we found we needed small steps. In addition, we want the rubric to have enough information to provide guidance and still be readable and comprehensible. For those of you who would like more information about how to create the learning progressions, please see the Essentials of the Learning Progression model at www.reimagineschools.com. Grant Wiggins said, and I agree, to be useful, feedback must be consistent. Clearly, performers can only adjust their performance successfully if the information fed back to them is stable, accurate, and trustworthy. In education, that means teachers have to be on the same page about what high-quality work is. In an effort to make these progressions consistent and the feedback more stable, we use what we call anchor words associated with each developmental level of the learning progression. Not enough evidence means exactly that. If the student doesn't provide enough work or doesn't turn in an assignment or answer a question, there simply is no way for me to provide any feedback on whether or not he or she has mastered any portion of that practice. It's another way of saying, I reserve judgment. But since my job is to evaluate progress, earning not enough evidence means that a student really can't pass the course. Beginning means try to respond. Developing means responding with some relevant information. Proficient means the student explicitly uses physics in their response. Advanced means the response is accurate, and expert means the response is complex or sophisticated, usually by tying in multiple concepts. These are the words that I use to try to keep everything uniform. I like to use the analogy of a ladder for performance levels. One must step on the previous rung before attempting to move to the next one. Therefore, students must achieve beginning before they move to developing. Notice how, unlike a real ladder, these rungs are not like equally spaced out. That's because as you move towards more complexity, there are many more items to address, and so it's a lot more to manage. So we move pretty quickly initially from beginning to developing, and then we spend a long time working on proficient and even longer to get to advanced. And you'll see this when we get to talk about how we develop these skills. Back in the video, The Practices, I presented all 10 practices and their goals. Here's one, creating explanations and making predictions. The goal is to show what physics you know and can apply from the current unit of study. The physics can take the form of overtly stated definitions, laws, mathematical models, equations, or relationships. So how does that translate into a learning progression? The first thing that a student should do is try. Write an explanation, any explanation that they believe will answer the question. You can't produce a right explanation if you don't begin by writing something. The next step is to use the applicable vocabulary that you've picked up during class while learning the unit content. That's developing. Just be relevant. To build on that, define those terms so that I can tell you actually understand what they mean and how they apply. You could be wrong in that application, but the meaning of the physics terms should be correct in order to earn proficient. Only after that do we look for the application to be correct. And then the expert level draws in physics from other units of study. So we try to make progress using the skills throughout the year, even as the content changes. Let's do that again for another one. Let's talk about problem solving. The goal is solving scientific problems, right? Showing the process used. The problem-solving process includes givens and variables on a labeled sketch or illustration, relevant diagrams, equations used, numbers plugged in, and an answer to the question asked with necessary units on all values. So how does that translate to a learning progression? The first thing, again, that you should do is try. Write down any information that you believe will lead you to a solution. You can't possibly solve a problem if you don't start writing. The next step is to show any of the relevant steps that you've picked up during class, any of the ones listed in the descriptors. Listing givens, drawing a sketch, making some diagrams, putting down an equation, the numbers that you're plugging in, coming up with an answer, all of that is developing. To build on that, I have to be able to follow your work. You have to work systematically so I can follow your thinking, even if there are errors or omissions. You can be wrong in the application, but the steps themselves should be correct to earn proficient. Only after that do we look for all those steps to be completely correct. And again, expert level adds in complexity where strategies and information from multiple units are needed to solve the problem. Again, we're trying to make progress using the skills throughout the year, even when the content changes. In order to move students gradually from one level to another, we actually block out and don't let you view higher levels of achievement. Before the start of the year, teachers identify the goals for the class, and I backwards plan to set targets for each learning progression for every unit, with the goal of getting everyone to some previously identified level of performance by the end of the year. So why not just show you expert level from the beginning and let you try it? Well, there's research about cognitive load and executive function that tells us that we need to keep relevant learning to discrete chunks, reducing distractors and providing time to assimilate new skills before moving on to more complexity. So we think of each level as a stepping stone and a jumping off point for the next level. So if you're fully grounded in the beginning level skills, then you'll be ready to work on the developing level skills. By keeping each step attainable, we can reduce anxiety and stress associated with challenge. There will be much more on target levels in part 8, but let's first move to the next module in which we will discuss the different types of assessments that I use in this class.